the hole's not full of mud the right weight, then you could take a kick. And you're the one who's got to recognize a kick. You have a lot of equipment to help you detect kicks. Let's look at some of it. First, let's say you're on bottom drilling. One sign of a kick is an increase in the return rate of the mud coming back over the shaker. So, a return flow sensor can help. It has a paddle in the return line that's moved by mud flowing past it. The moving paddle sends a signal to a meter on the floor. It warns you if return flow increases. Another sign of a kick is a gain in pit volume. So another piece of equipment is a pit level indicator. It warns of a pit gain or loss. Floats in the pits sense the mud level and send a signal to an indicator at the console. As the floats in the pits move up or down, this indicator shows gains or losses. Of course, kicks happen while tripping too. During trips out, the volume taken up by the pipe and collars has to be replaced by mud. In other words, as you pull pipe out, you have to keep the hole full of mud. But how do you know you're putting in the right amount of mud? Well, a trip tank's a good way to keep track. Basically, it's just a small tank with a mud level gauge on it. When you turn mud from the tank into the hole, the tank's mud level should drop by an amount equal to the volume of pipe pulled. If it drops less, you've probably swabbed in formation fluids. You could be on the verge of a kick. So, to help you detect kicks, a lot of equipment's available, like return flow sensors that warn of an increase in return flow rate, pit level indicators that show pit gains or losses, and trip tanks that help you be sure you're keeping the hole full of the right amount of mud as you pull pipe. If workbooks are available, stop the tape and work exercise 1, then return to the program. Being able to detect kicks is the first step in well control. But once you recognize a kick, you have to control it. You have to keep the well from unloading and blowing out. To prevent this, you need shut-in equipment. You need blowout preventers. 3 basic types of blowout preventers are annular, ram, and drill stem valves. Annular and ram preventers seal off the hole, usually in the area outside the pipe. Normally, you use the annular preventer to shut in the well. But if it fails, or for certain special well control operations, you have the ram preventers. Usually there'll be at least 2 and frequently 3 or more ram preventers in the stack. This is because of the way they're designed. It takes at least 2 kinds of ram preventers to cover your shut-in needs. More about this as we go along. A drill stem valve may be needed when you take a kick while tripping. It seals off the inside of the pipe. Most drill stem valves are operated manually, but annular and ram preventers are operated best with hydraulic pressure. hydraulic pressure supplied by an accumulator, a blowout preventer control unit. An accumulator stores hydraulic fluid under high pressure in bottles or in spheres. In each bottle or sphere, nitrogen gas is highly compressed, often to 3,000 psi. The nitrogen puts pressure on the hydraulic fluid. Fluid pressure is the force that opens and closes the BOPs. A rubber bladder separates the nitrogen from the hydraulic fluid. Or sometimes a float is used instead of a bladder. But whether bladder or float, it keeps nitrogen from dissolving in the fluid and losing pressure. Okay, we have hydraulic fluid under pressure in the accumulator, ready to operate the BOPs. So let's operate one. Let's operate an annular BOP first. Basically, an annular BOP consists of a packing unit and piston inside a steel housing. To close it, you close the valve on your BOP control panel and pressurize hydraulic fluid in these high-strength lines that run from the accumulator to the BOP, enters under the piston. Fluid pressure causes the piston to move up. As the piston moves up, the packing unit squeezes inward until it forms a seal around the drill pipe. It'll also seal on the Kelly, drill collars, tubing, or on open hole. However, closing it on open hole reduces the life of the packing unit. So close it on open hole only if you have to. Fluid pressure from the accumulator also opens the preventer. Opening pressure moves the piston down, allowing the packing unit to move outward. A diverter is also a type of annular preventer. You might use a diverter when it's likely that you'll encounter a shallow gas zone. You can't completely shut in the well on such a zone. If you did, the shut-in pressure could easily be high enough to fracture the soft, loose formations near the surface, and you'd lose the rig. So, you can use a diverter. When closed, it shuts in the annulus as usual. But one of two large diameter vent lines is opened, and well flow is diverted through it. The flow's routed a safe distance downwind from the rig. The second kind of BOPs in a stack, the ram preventers, also operate with accumulator pressure. Basically, there are two types of ram preventers, pipe rams and blind rams. Pipe rams close only around drill pipe, and blind rams close only on open hole. Looking at pipe rams first, note that they must be sized for the pipe being used. For example, it takes 4.5-inch pipe rams for 4.5-inch pipe. However, variable bore rams are available. They can close on a variety of pipe sizes, like on 3.5-inch pipe, 5-inch pipe, or any size in between. Also, they can close on hexagonal Kellys, and in some cases even on square ones. Another type of ram is the shear ram. Shear rams cut through drill pipe and make a seal. You'd use shear rams in an emergency, like offshore on a floater, where you might have to get the rig off location in a hurry. You'd simply shear the pipe, leaving it sealed and suspended in the hole while you got the rig out of there. No matter what kind of rams are in the preventer, they'll have piston rods, pistons, and cylinders, all inside a steel housing. Closing pressure from the accumulator moves the pistons inward. Since the rams are attached to the piston rods, they also move inward. A packer on the face of each ram forms a pressure-tight seal around the pipe, or on open hole if blind rams are in the preventer. Bear in mind that no ram will close properly on a tool joint. It has to be on the body of the pipe, or it will not seal. Most ram preventers have an added safety feature. They can be locked closed. On some land rigs, you can turn large hand wheels to lock each ram after they've been closed hydraulically. On subsea stacks, and on many land stacks, the ram preventers can be locked closed by hydraulic pressure. Whether locked hydraulically or by hand, the rams will stay closed even if you lose accumulator pressure. So you have a lot of ways to shut in a well. You have annular preventers which close on any size of Kelly, drill pipe, drill collars, tubing, or on open hole. You have diverters that also close around the drill stem or on open hole, but allow you to divert well fluids away from the rig. Ram preventers include pipe rams that close around drill pipe of a specific size, unless you have variable rams that close around different sizes of pipe and even the Kelly. Blind rams can shut in on open hole. Shear rams cut drill pipe and seal the wellbore. They allow you to move a floating rig off location quickly. You also have accumulators that store hydraulic fluid under pressure and provide a way to close and open all the preventers just shown. If workbooks are available, stop the tape and work exercise 2. Then return to the program. No doubt about it, being able to shut in the well around pipe or on open hole is important. But if you're tripping pipe and take a kick, you must also have a way to stop flow out of the drill stem. This is where drill stem valves enter the story. Basically, there are 2 types of drill stem valves. One type is made up in the drill stem on the surface. The other is placed in the drill stem down hole. Let's look at surface types first. This is a ball valve. When the ball is in open position, drilling fluid can pass through it. You open and close this type of valve with a special operating wrench. When closed, the ball forms a pressure-tight seal against flow in either direction. The ball valve can be used in 3 different places in the drill stem. First, you can use it as a Kelly cock, or upper Kelly valve. When made up above the Kelly and closed, it shuts off kick pressure in the drill stem to protect the swivel and rotary hose. Second, you can use it as a lower Kelly valve. Used here, it's often called a drill stem safety valve or a mud saver valve. It allows you to shut in the drill pipe with the Kelly up. Third, you can use a ball valve as an inside blowout preventer. When the Kelly's in the rat hole during a trip, the valve, in its full open position, can be stabbed into the top joint of drill pipe. Then you close the valve to shut off flow. Keep that operating wrench at a special place on the floor. You may need it in a hurry. A dart valve is another type of inside BOP that's stabbed into the drill pipe. A lock screw holds a rod down. The rod keeps the valve pushed open against pressure from a spring. This allows you to stab the valve against flow out of the pipe. Back out the lock screw to release the rod. The valve springs closed to shut off flow. As for downhole inside BOPs, one type is a drop-in check valve. First, a special landing sub is made up in the drill string, usually right above the drill collars. This is done during a normal trip in. With the sub in place, then all you do is drop the check valve into the drill string and pump it down to the landing sub. The valve seats on the stop ring. Normal circulation keeps the valve open. But if a kick enters the drill string, upward flow is stopped by the spring-loaded ball. Also, a packer expands to form a seal, and serrated jaws activate to keep the valve in place. So drill stem valves are needed whenever you have to shut off backflow in the drill stem. You have the upper Kelly cock, the lower Kelly valve or lower Kelly cock. Inside BOPs, you can stab when the Kelly is removed. And a drop-in check valve, you can pump down the hole. If you have workbooks, stop the tape and work exercise 3. Then return to the program. Once you get the well properly closed in on a kick, you have to circulate kill weight mud in, circulate mud and the kick out, and hold adequate back pressure on the well. Normally, you circulate kill weight mud into the hole as usual, down the Kelly and drill string. But you circulate mud and the kick out through a choke line, a line coming out of the stack below the closed preventer. First, you have to open the choke line with a valve, often called the HCR valve. The HCR valve can be remotely operated from your BOP control panel. Once the choke line is open, mud and kick fluids flow to the choke manifold, an arrangement of valves, fittings, and lines. It gives you a choice of several routes for return flow. For instance, you can vent well fluids through a bleed line. Bleeding off the fluids holds a minimum amount of back pressure on the well. Usually, though, you direct the return flow through one of several chokes. A choke is a special valve with an adjustable opening. By opening or closing it, by adjusting it, you can regulate back pressure held on the well as you circulate out. Normally, you circulate through a remotely adjustable choke. You can adjust this choke from a panel on the rig floor. In other words, from this panel, you can open and close the choke to adjust it, and read its effect on back pressure on the shut-in drill pipe pressure gauge and on the shut-in casing pressure gauge. Plus, most choke control panels have a pump stroke counter so you can keep track of kill weight mud going into the hole. After leaving the choke manifold, returns may be piped to a mud gas separator, especially if you're shut in on a gas kick. Here the separator's the gray cylinder at right. A mud gas separator is a vessel that provides an enclosed space for gas to break out of the mud. The gas is then vented a safe distance away from the rig. The mud goes back to the pits. So, to circulate mud and kick fluids out of the well, you usually circulate through the choke manifold, an assembly of valves, fittings, and lines that allow you to direct return flow and control back pressure on the well. Usually, you direct returns through a choke. Adjusting the opening in the choke gives you control of back pressure. And finally, if you're closed in on a gas kick, the returning mud and kick fluids can be piped to a mud gas separator. So you do have a lot of good equipment to help you detect and control kicks. As for kick detection, you have flow sensors that warn you of an increase in the return flow rate of the mud. Pit level indicators that can warn you of pit gains or losses. And trip tanks, which help you be sure you're keeping the hole full of mud when pulling pipe. In the area of control, you have blowout preventers. Annular preventers that close on any size of Kelly drill pipe, drill collars, tubing, or on open hole. Diverters that also close around the drill stem, but allow you to divert flowing well fluids away from the rig. You have pipe ram preventers that close around drill pipe or tubing. Blind rams to close on open hole. Shear rams to cut pipe and seal the well. And accumulators to operate the annular and ram BOPs. For kicks inside the drill stem, you have drill stem valves. You have the upper Kelly cock, the lower Kelly cock. Inside BOPs, you can stab when the Kelly is removed. And drop-in check valves you can pump down the hole. To circulate kicks out of the hole and to maintain adequate back pressure on the well, you usually circulate through the choke manifold. In the choke manifold, you have chokes that you adjust to keep proper back pressure on the well. And finally, you have mud gas separators that knock gas out of the mud as it leaves the choke manifold. But good well control is something more than good equipment. It's you and your crew. It's people. Well-trained people and good well control procedures, along with good equipment, can make the difference between this or this. If you have workbooks, work exercise 4.